This video is going to concentrate on pH titration curves. There are 4 curves we need to look at. In an exam situation, you would more than likely only be faced with one of 3 of the curves we're going to look at. Okay, but we need to be able to recognize all 4 shapes. The first curve we're going to look at, where we look at titrating a strong base. So strong base that we will look at would be sodium hydroxide and a strong acid. Okay, so the strong acid we are going to look at would be hydrochloric acid, HCl. So we're going to look at a situation where you would have hydrochloric acid in a beaker, in a conical flask rather. Okay, and we're going to say that there is 25 mils of hydrochloric acid in that conical flask, okay? And we're going to add then from our burette, okay, that we're going to add our NaOH. Now you might be looking at this and realizing that when we actually carry out titrations in the lab, that we would usually have our base in the conical flask and our acid in the burette, but for the purpose of these curves we usually look at the base being added to the acid. Now we're also going to say that we have our acid and our base, that they are the same concentration. So just for this example, we're going to say that they're both 0.1 molar. It doesn't really matter what concentration we have, just as long as we're saying that they are both equal for this curve. Okay, so we're starting with a solution of hydrochloric acid. Hydrochloric acid is a strong base, so it has a low pH. Okay, so we're going to start our curve, and this is why it is drawn in your book like this as well. Okay, we're going to start our pH because we're starting with a solution of acid, of hydrochloric acid, strong acid. Your curve is going to start down here at about a pH of 1. Now, okay, and as you start to add your base, it becomes slightly more and more alkaline. Okay, now we have 25 mils of hydrochloric acid starting. These figures down here represent the centimeters cubed of your base that is being added. So when we get to 25 centimeters cubed of NaOH being added, you'll see that the curve goes almost vertically up. Now, the reason for this is that when you have 25 mils of NaOH added to your 25 mils of hydrochloric acid, you have the same volume of both, and they're both the same concentration. So that means the number of moles of each is also equal. Now, okay, so this line goes straight up because, as you know, that when we're actually practically carrying out titration, 1 drop, okay, less than a mil could be the difference between your indicator staying one colour and changing to another. So that's why there's this long vertical line in the middle, because if you add even 1 drop excess base, well then your solution becomes alkaline. And because we have we're using a strong base, we're using NaOH, it's going to go to quite a high pH. So we're going for a pH of about 12 or 13. So this is all caused by excess base being added to the solution. Now, in questions then, you can be asked what a suitable indicator would be. Okay, when you're asked what a suitable indicator would be, you're looking at the range of pHs that this line is vertical for, because it's along that line that the indicator will work. Okay, so these ranges you have to learn off, I'm afraid. Okay, the ranges for 3 of the indicators that are on your course are, we'll move down here maybe. We have litmus, which works in a range of between 5 to 8. We have methyl orange, which works in a range of 3 to 5, and we have phenolphthalein, okay, which works between the ranges of 8 and 10. Okay, so even there you might realise that since junior cycle you've been learning that an indicator to identify an acid and a base is litmus, and that's because litmus works in a range of between 5 and 8, 5 being acidic, 8 being alkaline. Okay, whereas methyl orange only works for acids between the range of 3 and 5, and phenolphthalein only really works for bases between 8 and 10. So, we're lucky for this one that when you're using a strong acid and a strong base, all 3 of those indicators would work, because they are all between this, where this line is straight. So this line is straight for roughly between 3 and up to just above 10. So litmus, phenolphthalein and methyl orange will all work for strong acid, strong base titration. Now, if we look at the next type of curve we have to look at, we would be looking at a strong acid and a weak base. Okay, so a weak base that we would have come across would be NH3. Again, we're going to have the same concentration being used, and this time this is going to be NH3. Now, so the beginning of our curve is similar. Okay, we're starting with hydrochloric acid. Again, when we get to 25 mils, you'll have an equal volume and equal solutions of equal concentration, so you're going to have equal number of moles. So when we get to 25 mils again, you're going to have this sudden increase. But this time we're using a weak base, so this line isn't going to be vertical for as long. Okay, so this line, isn't going to stay vertical for as long. It's only going to just about pass pH of 7, and then you're going to start to see it curve. Okay, so this would be caused by excess base being added, which can be caused by even just one drop too much of base being added, and your solution becomes alkaline. Okay, so then we need to, if we're looking at what indicator would be suitable for this, we would look at our ranges for where this line in the center here is straight. Okay, so it's only straight from about from 3 to about 7. Okay, that's our range that we're working with. The only one of our indicators that stay within that range is methyl orange, that works between the ranges of 3 and 5. Litmus is between 5 and 8, so that's not an option. And phenolphthalein is definitely not an option because it works between 8 and 10. The next curve we're going to look at is a strong base. So again, we're going back to sodium hydroxide, NaOH, 0.1 molar. And weak acid, we're going to use we're going to use ethanoic acid. So CH3COOH. Again, 0.1 molar. We're starting again with your CH3COOH. We're going to start with 25 centimeters cubed of that, 0.1 molar again, and we're going to be adding a strong base, so NaOH again. Alright, so this time we're starting with a weak base, so we're actually going to be starting in around a pH of 3. Okay, and again we're going to start adding our base, and again there's a very gradual increase to start, gradually rising, no major increase. Okay, so I might just redraw that. Okay, so again, starting off at 3, adding your base gradually, and again, when we get to our 25 mils, there's going to be this sharp increase in pH. Okay, so we have this starting with a weak acid. We're titrating against a strong base, so our pH in that one drop, or where you want to phrase it, of 25 mils, you're going to go from having an acid to quite a strong base. Okay, so we're using a strong base, NaOH, so our pH is going to go up into about 12 or 13 again. Okay, so starting with a weak acid, you're starting pH 3, titrating it with a strong base, you're going to have a pH in the end of about 12 or 13. Again, choosing what indicator to use. Of course, your methyl orange between 3 and 5 isn't going to tell you anything, because it won't give you a good endpoint. Okay. Again, litmus between 5 and 8 isn't going to work for you, so here you have to use your phenolphthalein, because that range is in between 8 and 10. And the last curve that we just mentioned briefly is between a weak acid and a weak base. So here again we have NH3, so ammonia, and we have our ethanoic acid. Again, same concentration, 25 mils of your hydrochloric acid. Here, this titration wouldn't occur in a lab because we can't calculate any concentrations of it, because we don't have any endpoint from any indicator. No indicator will give us a clear endpoint, so this type of titration wouldn't really occur, and you wouldn't be asked this in an exam situation. Okay, it is on your course, you have to be able to recognize it, but highly unlikely that you would be asked anything about it on an exam. Okay, so here again, around 25 mils, you have this brief straight line. Maybe you're near to straight anyway, as you're kind of transitioning from an acid to a more alkaline solution, but nothing clear enough to be able to use an indicator. Alright, so I hope that helped.